Um, Good day. Welcome to Simon Link's online tutorial class. This is the very first of our video, and today we're going to be doing some bit of maths. And the math topic we're going to be looking at is quadratic equation. Just come alongside with me as we proceed to introduce the topic. The very first thing that we will need to learn how to do, or that we'll need to be able to do first, will be to define a quadratic equation, to essentially state what a quadratic equation is. And we're going to start it on a very simple scale. We'll define a quadratic equation. We'll describe the various forms in which it can come, and we'll describe the methods by which it can be solved. We'll only talk about the methods. We will not really solve examples on them in this first part video. Subsequent videos will actually illustrate how it can be solved. We'll only just describe them generally and how we utilize them. Okay? So first and foremost, we need to define what a quadratic equation is. And from there, we'll proceed to other very important aspects, which is methods of solving a quadratic equation. Definition. So a quadratic equation is any equation that actually has this particular ax squared plus bx plus c. Clearly, as you can see, the highest power of a quadratic equation is actually x squared. A, b, and c are constants. They are numbers. They stand in for different numbers. And the condition for which this will remain a quadratic equation is that the coefficient of the x squared must never be 0. B and C can take on a value of 0, but the coefficient of the x squared term must never be 0. In that particular case, it means there are a lot of possibilities that can actually come up as quadratic equation. The first possibility is the possibility where the C is 0. For instance, if you have a quadratic equation like this, x squared plus 3x is equal to 0. In this particular case, A has a value of 1, not 0. B has a value of 3, but C has a value of 0. This is the quadratic equation in itself, and any formula that works for this will also work for this. Another special case will be the case where the middle term, that's B, is equal to 0. See, this is the case where C is 0. Another special case will be the case where this is actually equal to 0, b is equal to 0. So we could have 3x squared minus 3 is equal to 0. So this is a special case with b being equal to 0. A third possible special case will be in the event where both b and c are equal to 0. Of course, if b and c are equal to 0, you get something as simple as 4x squared is equal to 0. That's both b and c have a value of 0. But in the event that neither b or c are 0, you have the general quadratic equation, which could be 3x squared, for instance, minus x minus 2 is equal to 0. In this particular case, both b and c are non-zero. All these are forms in which the quadratic equation can actually exist. All these are forms in which the quadratic equation can actually exist. So anytime you see anything that looks like any of those four categories, they are all quadratic equation. Remember, the only thing that makes this not a quadratic equation is if there is no x squared anywhere. The only thing that will make this not a quadratic equation is if there is no x squared anywhere at all. Okay? But as long as there's an x square, as long as we have an x square somewhere, then there is a quadratic equation. And what are the methods for solving quadratic equation? Well, so far in mathematics, the techniques or the method of solving quadratic equation are 4 in number. The first method that will be considered here under description is the graphical method. In this method, a graph of the quadratic expression is actually plotted for different values of x. And different values of x are actually imputed and different values of y actually obtained. And then a graph will be plotted. And that particular graph usually has two major shapes. It's either it's a U shape up or an N shape down. It either has an upward parabola or a downward parabola. The name for the curve is a parabola. So this is a minimum curve anyway, and this is a maximum curve. But if we want to get the solutions or the roots to the quadratic equation, because another name for the solution to the quadratic equation is also called the roots, all we need to do is to check where the parabola cuts the x-axis of the graph, where the curve cuts the x-axis of the graph. Once we can locate those points where it cuts the x-axis, those are the solution to our quadratic. Those are the solution we are looking for. So any quadratic equation either has this form or this form. It has a minimum when a happens to be positive. If this a is positive, it will have a minimum. If a is negative, it's going to have a maximum. Okay? The second method available is the factorization method. This method is quite simple and very easy to use. However, this method is not always the best to implement. The reason is because sometimes the quadratic equations do not have rational numbers as factors. They do not have rational numbers as factors. Sometimes the roots of the quadratic equation are irrational, and if they are irrational, you cannot use the factorization method to solve them. We're going to see how to use the factorization method to solve the quadratic equation in a subsequent video. Same with the graphical method. Another very important method is called the completing the square method. Completing the square method. In the case of the completing the square method, it's an approach that always works, where the factorization and the graphical method probably has failed. The truth is that it is not all graphs that when you plot them, you will have them passing through the x-axis. Some graphs don't touch the x-axis. They could either be above the x-axis or below the x-axis, but they don't cross or touch the x-axis. In such a case, the completing the square method makes it quite obvious for us to be able to solve such kind of cases. Usually those cases are cases with imaginary roots, and the completing the square method gives us the imaginary root. The graphical method cannot give us the imaginary root, and the factorization method cannot give us the imaginary root, but the completing the square method gives us the imaginary root. But because the completing the square method was a little bit too long, one of the major things that must be done was to transform it into a formula. And so it led to the fourth method, which is called the formula method. The formula method was derived from the completing the square method. It's more or less like a shorter way of accomplishing the completing the square method. And so the formula method will also be used in a subsequent video. All of this will be used using one particular example just to illustrate and to teach that all these methods will give the same answer. So these are the various methods of solving the quadratic equation: the graphical method, the factorization method, the completing the square method, and the formula method. And they will be discussed in detail in subsequent videos. So if you like this video, please like us on Facebook and our social media handles. And you can also share the video. You can also go to the Sam Keda page where most of this will be thoroughly discussed and explored. Thank you for watching.